Hi students, today I am going to discuss the hash functions. In the authentication functions, there are three important functions are there in the cryptography. The first one is the MAC function, and second one is the message encryption, and third one is the hash function. Coming to the message encryption, the ciphertext of the entire text produces as its authenticator. So that means the ciphertext of the entire message produces as its authentication. And coming to the MAC function, that is message authentication codes. So what the message authentication codes are nothing but a public function and a secret key which produces a fixed length hash value which serve as its authenticator. So in the MAC function there is a key, so both can be added and produces a fixed length value which serve as its authenticator. And coming to the hash function, so the hash function is nothing but a public function which maps a message in any length into a fixed length hash value which serve as its authenticator. Now we can see the difference between the MAC and hash. Here in the MAC function there is a key, but in the hash function there is no key. So what the concept of this particular hash which can be converted a variable length into the fixed length. Now you can see this diagram. So this is very clear. The message M is an arbitrary length in the sense that is the various length. The various length can be divided into the fixed length, that is the hash value. So now you can observe this is the hash function. So simply we can represent this one is the hash function. So this hash function is nothing but to convert the variable length message into the fixed length message. So this is what exactly, that is without key. So coming to this, so hash functions are extremely useful and appear in almost all information security applications. In any security related applications of information security, so all the information security applications are depends on the maximally the hash functions. So this hash function is a mathematical function that converts a numerical input value into another compressed numerical value. Now you make it observed how it can be converted into the variable length into the fixed length. So because of this hash function is a mathematical function. So this is the first one, it is purely related to the mathematical function that converts non-numerical input. So non-numerical input is converted into the compressed numerical value. So this is the major identification of the hash function. The input to the hash function is of arbitrary length, but output is always in the fixed length. So that means whatever the input is taken into the hash function, so that is nothing but the numerical input, so which has to be a various length and which can be converted into the fixed length using the hash value. And coming to these values returned by the hash functions are called the message digest. So whatever the values which can be produced after the hash function, so all the hash functions which are taken in the message digest or simply hash value. So that means the simply hash values. So coming to this picture, we already identified this. The variable length message M is converted into the fixed length value which is taken the hash value. Now coming to this, you can observe this one is the keys. John Smith is one of the key, that is the name of the key. So that name of the key is identified one of the hashes with the help of the hash function. So we already said the input of the hash function is nothing but the non-numeric. So numeric. So non-numeric is converted into the numerical value. So the keys are nothing but the non-numeric, where these non-numeric values are applied to the hash function. So the hash function is converted into these numerical values into non-numerical values into the numerical value. So that's why simply you can understand this. So this is a non-numerical, and this non-numerical value is taken the numerical value too. Now you can observe the keys of the John Smith is converted into the numerical value, that is the 2, with the help of the hash function. So now similarly the Lisa Smith is the one of the name. This is also the non-numeric. The non-numeric is derived the numerical value, that is the 1. And the Sam Doe is one of the key, so that may be converted into numerical value, that is the 4. And similarly the Sandra D is also converted into the some more numeric. So that means the non-numerical values are converted into the numerical values which are taken with the help of the hash functions. So this is the main concept of the hash function. So the basic uses of the hash functions are, now you can observe this diagram, the hash function without having any key. So directly the message M is applied to the hash function. Now it will be converted into H of M. So now the H of M is concatenated. Now you can observe. So this particular H of M is concatenated with the original message M. So with the original message M, and finally apply the encryption with the key K. So what the output is, the EK of H of M is concatenated M. That is an output of. So what the hash function is nothing but a public function which maps a message in any length into a fixed length value. So how we can converted this particular encryption pattern, because of, so H of M is already cryptographically protected and concatenated with M, and finally all the message should be encrypted with the help of the key. So that's why here the EK of, so M concatenated H of M. Now that message is taken to the decryption with the same key K, and finally we have to be taken the H of M message. Now we can apply the hash function to the M message, and if both are equal, that means the H of M messages are equal, then it produces as its authenticator. So now you make it, I observed this particular H of M messages, if both sides are the equal, then it produces as its authenticator. And similarly you can observe the different configurations of these hash functions can be taken place. So the hash function is applied to the M. After that immediately you can apply the encryption. This is one more, because of, so the hash function and the key combinations can be taken in the different way. So before concatenation, after concatenation, and immediately we can apply the encryption after applying the hash function, like that. So that means the different types of the combinational factors of the hash function and encryption function. Now we know that in total cryptography, conventional crypto system is that, so that means the single key is operated on both sides of the senders and the receiver. So here also you can observe the first two diagrams. So that is a conventional crypto system. The single key is operated on both sides of the sender and the receiver, or the source and the destination. Now you will make it observe this particular key is applied before concatenation and after concatenation. In the first diagram you can observe the concatenation can be taken between the M and H of M. After that we can apply the encryption. And here second diagram, so whenever we can apply the hash function, immediately we can apply the encryption function, then we can concatenate. So the two diagrams is the two combinational factors. So before encryption and before concatenation apply the encryption, after concatenation apply the encryption. Coming to the third diagram, it is a public key cryptography. So initially the sender A can generate the pair of keys. So if the sender can generate the pair of keys, so the sender must uses his private key in the encryption. That is a concept we know that, because of the sender does not send his private key to anybody, because of the secrecy is in private key, not in public key. So that means the KRA is used here. So whenever KRA is used, so definitely the sender can generate the pair of keys. Suppose for example, if the recipient can generate the pair of keys, he must send his public key to the sender. So whenever the sender can encrypt the data, that is with the help of the public key of the recipient B. Now you can observe in this diagram. So this is this particular diagram. So this KRB can be used with the public key of the recipient. So whenever he can be applied, this is nothing but the confidential message. So in the second one, if he generates a pair of keys, the sender generates a pair of keys, the sender uses his private key in the encryption. Here is the two combinational before after concatenation. So we normally directly send to the destination. After concatenation, applying the hash function and encryption, again we can confidential key can be applied here. Here you can observe this is the conventional crypto system. Again the confidential is applied here. The single key is again the applied here, and after that if both are concatenated or equal, then produces as its authenticator. Now coming to this particular, the next one, suppose a session key is generated. Now you know that the timestamp, session key is nothing but, so whenever both users are communicated a very secured manner, so immediately they can identify the session key. A session key is used to concatenated M. After that, so we have to apply the hash function. Why? We can we can't apply this particular session key to the hash function. So because of this particular hash function doesn't have any key. The concept of the hash function is, so it doesn't have any key. That's why, so the session key is separately used, which is added to the message M, and these two are concatenated, and finally we can prepare the message. And in the destination side, if both our messages are equal, then it provides as its authenticator. And finally you can observe, hash function is applied similarly. So after taking the session key with the combination of the message, and here the encryption is additionally added. So whenever the encryption is additionally added, then it can be combined the final messages. So then it can be produces a fixed length value which serves as its authenticator. So this is an hash function.